So we'll do the fifth sum on Black and Scholes model today. They've asked from the following information relating to ABC Limited, identify the values of a call and a put option using Black and Scholes model. And they've also asked us to determine the values of the derivatives of Black and Scholes model. Derivatives are nothing but the option Greeks, that is delta, gamma, theta, vega, and rho. So those also they have asked us to find. So let's take the information and start doing it. The very first thing that we need to find is the value of D1. So here we have all the information. We'll put it in the formula of D1 and find the value of D1. This is the formula for D1. D1 is equals to natural log of S naught divided by E. S naught is 120 divided by E is 115 plus R. R is nothing but the rate of return. Rate of return is 10%, 0.1 plus 0.5 into standard deviation square. Standard deviation is 0.6. So we have to find the square of this into T. Time is 3 months, so 3 by 12. The whole divided by standard deviation 0.6 into square root of T. 0.6 square we have to find. So C1 is equals to natural log of 120 divided by 115. 0.0425 is what we get, plus standard deviation square we'll do first. So 0.6 into 0.6 is 0.36 into 0.5 plus 0.1 into 3 divided by 12. We get it as 0.07. This is the numerator divided by square root of 3 divided by 12 into 0.6. 0.0425 plus 0.07 divided by 0.3. 0.375 you get as the value of D1. Is everybody getting this? I hope all of you are getting 0.375. Anybody? Can you confirm?
Yes, ma'am.
Okay. Now we'll find D2. We know the D1 value 0.375 minus standard deviation into root T. D2 will be equal to 0.375 minus 0.3, 0.075. These are the values of D1 and D2. Now we can find in D1 because D1 is positive, so 0.5 plus. Okay, we need the table values, right? All of you, I had shared the table value with you on the WhatsApp. Just check. Just give me 1 minute. And just can one of you just share it uh, on the group again, because I'm not able to download it from there. I had shared it on the group, right?
I'm not able to see it on group.
Yes, ma'am, me too.
Not able to send.
No, ma'am, we
Ma'am,
are not
it's
able to
not
find
there
it.
in group.
Yes, ma'am.
Ma'am, I'll check once again.
Okay. You all have it with you, no?
No, ma'am.
No, ma'am.
I think I've not shared it on the group.
Yes, ma'am, it's not shared.
It's in my laptop, and I've come to the college today, so I'll tell you the answers. The table value will solve the sum, and I'll share it once I go back home. Okay, or I'll
Okay,
take
ma'am.
a picture from the office and I'll share it. Okay, so when we see the table, I hope till now you're familiar as to how to see the table. So when we see the table, we take the only first two digits after the decimal. So we have to see 0.37, 0.3, and we go up to 7. So when you see 0.37 in the table, the value that you get is 0.1443. So ND1 is equals to 0.5 plus 0.1443, that is 0.6443.
Ma'am, the screen is not visible.
It's visible now.
Yes, ma'am.
Yes, ma'am.
ND2 is equals to 0.5 plus ND2. We have to take the first two digits after the decimal, that is 0.07. So 0.0 in 7 we check. So when you check 0.0 in 7, you get the table value as 0.0279. 0.5 plus 0.0279 is 0.5279. So these are the values of ND1, ND2. Now we can find the value of a call option. So C is equals to S naught. S naught is 120 into ND1, that is 0.6443 plus, sorry, minus E into E raised to minus RT. So E is 115 into E raised to minus R is 0.1, that is 10% into 3 by 12 into ND2. ND2 is 0.5279. So we need to take this as raised to, so C is equals to 120 into 0.6443 77.316 minus, we'll find the present value 115 into, first we'll find the E raised to minus 0.1 into 3 by 12. You get it as 0.9753 into 115 if we do 112.16 112.1606 into 0.5279, we get 59.2095. So C will be equal to 5977.316 minus 59.2095, 18.106. This is the value of a call option. All of you are getting this?
Yes, ma'am.
Now let's do it for put option. Now to solve for put option, we need n minus d1 and n minus d2. So n minus d1, which is nothing but 0.5 minus, we have to see the d1 value and minus it. So it is 0.1443. 0.5 minus 0.1443, we get 0.3557. N minus d2 is equals to 0.5 minus 0.0279, which is equal to 0.4721. Now we can put the values in the put option formula. P is equals to E into E raised to minus RT, that is 115 into E raised to minus 0.1 into 3 by 12 into N minus D2. N minus D2 is 0.4721 minus S naught 120 into N minus D1, which is 0.3557. So P will be equal to 112.1606 into 0.4721. After finding the present value, you get 52.95 minus 120 into 0.3557, 42.684. So if you minus both, get the value of put option as 10.266. Just 1 minute. Okay, so everybody getting 10.266.
Yes, ma'am.
Now they have also asked us to find the option derivatives, or we also call it as option Greeks. So first thing that we are going to find is the delta. So to find the delta, you know the formula which I had given in the last class. I've written it here as well. Delta for a call option is equals to ND1. So that is equal to, we have already found out ND1 value above when we were doing call option, that is 0.6443. So ND1 is 0.6443. That's the value of delta. And for a put option, it is ND1 minus 1. So 0.6443 minus 1, which will be equal to 6443 minus 1 minus 0.3557. So increase in the stock price is good for a call option, so the delta is positive, and it is bad for a put option, so the delta is negative. Because for a call option we do S naught minus E, and for a put option we do E minus S naught. So this is how delta helps us to find by how much the value of the option will increase or decrease if the stock price increases. So if the stock price increases by 1 rupee, your call option value will increase by 64 paise. If the S naught increases by 1 rupee, your put option value will decrease by 35 paise. This is how you need to interpret delta. The next option Greek, or the next derivative of option, is gamma. So for this, we need to first find ZD1, which is the formula here, because in the main formula we have to do ZD1 divided by S naught into standard deviation into root T. So before we do that, we need to first find the ZD1 value. So let's do that here. ZD1 is equal to e raised to, so this is the exponential, e raised to minus this d1 square divided by 2. So this is square to go up. Okay, so e raised to minus d1 square divided by 2. Okay, so square means it has to go up. And this entire thing is also raised to. So e raised to minus divided by square root of 2 pi. So pi is nothing but 22 by 7. So we need to do 22 by 7 and whatever value we get. Just one second. So divided by square root of 2 into pi. Pi is 22 divided by 7, which is 3.1428. Okay, this let's solve this part now. ZD1 is equals to, okay, we know the D1 value, we have to take that directly here. D1 square we need 0.375 is D1. So 0.375 square divided by 2. We get
0.9321.
0.999321
9321.
everything.
Yes, ma'am.
0.375 square you're doing, no?
Yes, ma'am. Ma'am, I did e raised to 0.07031.
0.07031. Okay. Shift ln minus 0.07031. You get 0.9321 divided by square root of 2 into 3.1428. So you get 2.5071. Divide both, you will get the value of ZD1. Nine three two one divided by 2.5071. 0.3717. Getting it, Sharvari?
Yes, ma'am.
Now we have the ZD1 value. Now we can find the gamma value. So we'll write here gamma is equals to ZD1, which is 0.3717 divided by S0 120 into standard deviation 0.6 into square root of T. That is 3 divided by 12. So we need to multiply all these three. So gamma is equal to 20 into 0.6 into square root of 3 by 12. 36. So 0.3717 divided by 36. 0.010.
0.0088.
0.0.
Ma'am, 0.31. Sorry, ma'am, I did something wrong.
0.010 I have got.
Yes, ma'am, I also got that only.
So this is the value of gamma, and gamma will tell you by how much the delta will change. So it has no significance with the change in stock price and all those. It is just interpreting by how much the delta will change if the stock price changes. Now let's find the value of theta. Now theta value is different for both call and put option, and remember it always starts with a minus sign because theta means the loss of time. As the time passes, the value of a call option decreases. So we also call it as time decay. So if it is a 3-month contract, at the beginning of 3 months, its value will be high. After 1 month is over, only 2 months will be left. That time the value will come down. So as the time passes or as we get close to the maturity, because the time is less for making decision, the value of the option reduces. So we find theta for a call option first, which is equal to, it always starts with a minus sign. So minus S naught ZD1, S naught into S naught is 120 into ZD1 we found out in the above case 0.3717 into standard deviation which is 0.6. This is the numerator divided by 2 into root t. So 2 into square root of t, that is 3 divided by 12 is the value of t. So this entire thing we need to first find, and then we need to minus this again with e into e raised to minus rt. So 115 into there above, I'll just take it from there itself. E into e raised to minus rt into r. R is 10%, so 0.1 into ND2. We'll see what's the ND2 value. ND2 is 0.5279. So theta will be equal to minus, first find 120 into 0.3717 into 0.6. 26.7624 divided by 2 into square root of 3 by 12. 0.2886. This is the numerator, or this is the equation. From this we have to minus 115 into e raised to minus rt, which is 0.1 into 3 divided by 12. 112.1606 into 0.1 into 0.5279. So we write the final answer now of the theta. 26.7624 divided by 0.2886. get 92.731. So minus 92.731 minus,
Ma'am, it's divided by 1, right?
divided
Yes,
by
ma'am,
1.
I'm also getting 1.
This 2 into square root of 3 by 12, you're getting it as 1.
Yes, ma'am.
0.5.
What you're getting is 1.
Ma'am, 2 into square root of 3 by 12, it is 1.
Square root of 3 by 12, when I find,
Ma'am, it is 0.5.
0.5 into 2, yeah, that is 1. So 26.7624 divided by 1 is the same, 26.7624 as it is, minus
59.209.
59.208.
209. 9, ma'am.
Theta is equals to, both are minus, so minus 26 point. Just check this, 59.208 or 5.9 it is,
Ma'am, 5.9.
5.9. 5.9209. So minus 26.7624 minus 5.9202. You get 36.6329. Sorry, 32.6329. Check any other answer if you're getting. Thirty-two point six eight three three. Are you all getting it? Both are minus, so they'll get added up and higher number sign will be taken there. Is that clear? All of you getting it?
Yes, ma'am.
Now theta for put option, I'll give you the answer. You can try it at home. Minus 21.4168. The same method we're going to use which we did above. Only difference here is instead of n d2 we take n minus d2, which is, you have found it for put option already, n minus d2 0.4721. So you need to take that. Rest everything is same. So only this value is changing. Change it and see, this is what the answer you will get for theta. Now let's do Vega. Vega for a call or a put option has the same formula. So Vega is equals to S naught, that is 120 into square root of T 3 by 12 into ZD1. ZD1 we found above. Let's just take it from there, 0.3717. So Vega will be equal to 120 into square root of 3 divided by 12. in, into 0.3717. 22.302. You all getting this as Vega? The last part is rho, the two formulas for rho. Just check Vega. Did anybody get it? Confirm.
Yes, ma'am. 22.302.
Okay. Rho also has two formulas. E, that is 115, into T, that is 3 by 12. First we need to multiply these two and then find its present value, into e raised to minus RT. In once you solve this entirely, into n d2 we have to take. So n d2 value 0.5279. So is equals to 115 into 3 divided by 12. 28.75 into e raised to minus RT, 28.040 we get, into 0.5279, 14.80. Just see all of you getting it as 14.802. Is that okay with all of you?
Yes, ma'am.
Now for put option theta, the same formula, but it starts with the minus sign. And here instead of n d1, it is n minus d2. So the value of rho, I'm giving you the answer. You can try it at home. You'll get it as minus 13.237. Okay, now I want to tell you one thing about rho. When we calculate rho, it basically measures if the interest rate changes, by how much the value of a call option will change. So usually when you get 14.802, that doesn't mean that by 1% change in interest, the value of call option will change by 14 rupees. So what we do is, if you want to know from 1% point of view, you should do 15.802 divided by 100, because there are 100% if you want in percentage terms. So if I do that, I get 0.14802. So here this you can interpret like, if 1% increase in interest rate, the call option value will increase by 14 paise, or 14 or 15 paise roughly. And here also we need to do it divided by 100. So if 1% increase in the put option, the value of the put option will decrease by 13 paise roughly. So this is how you find for 1%. This is for 100% increase. So if the interest rate increases 100%, you will earn 14 rupees extra on the call option, and you will lose 13 rupees on the put option. So here also rho, you can make it equal to minus 13.273 divided by 100. So you will get per 1% increase or decrease 0.13273. So put option will decrease by 13 paise odd. So this was the fifth problem. I hope it was clear. Anybody having any doubts? Was that fine for everyone?
Yes, ma'am.
Let's do the sixth problem. Now, in the sixth problem, they have not asked you to do option Greeks, only finding the call and put option. So, simple way we'll do it. And I have done two sums on option Greeks, that is delta, gamma, theta, vega, and rho. It is enough, I feel, because just the formulas that you need to remember and put the values correctly, you'll get the answer. So, we'll do this sixth sum. Or will you try it? It's a simple problem.
We will try, ma'am.
We will try
We'll
it, ma'am.
try. I will share the answers of this. I mean, I will post it, the answers. You check whether you're getting the same answers. So this one you try. The next one I will do it. The next one is about dividend. Now I had told you we'll do one sum when dividend is given. You see the above sum dividend expected nil. Before that also there is dividend expected nil. So till now there was no dividend and we solved the sums. Now if there is dividend, what has to be done? And usually when there is dividend, those sums come on index, not on per share. So Sensex or Nasdaq or any index that we have, on that usually the problems come. Okay, so here they've given dividend 2%. So the formula, all of you listen to me carefully. The formula has not changed majorly. Only thing is here we used to do R plus Q. I'm highlighting it if it's visible. I'll try to highlight it. Just a minute. It's not able to. Okay. Not able to edit it, but just check this part I'm trying to say. When you do ln s naught divided by e plus r minus q. So there's something called as q that has come up here. This q is nothing but the dividend. Remember when I did the first unit, I told you whenever you earn an income, you should do minus carry price model. There also we did S naught minus I when you earned a dividend. So here also this dividend has to be minus. There we had yield in percentage. So we used to do R minus Y in the first unit. Here we're doing R minus Q. Here dividend is denoted as Q. So that is the only thing that is additional. The call option, the put option formula don't change. C is equals to P is equals to R1 and the same. Only in the values of in the formulas of D1 and D2, here is what we have to take care. That is minus Q, R minus Q plus 0.5 into standard deviation square. That's how we need to solve it. Okay. So one sum I'll do now. One I have already solved for you so that you can practice it later. Okay. This cap sign is nothing but raise to sign. Just one minute. So we'll write down all this. This dividend rate is equal to Q. Okay. Which is 2%. All other things you already know. So let's put it in the value formula for D1 and solve it below this. D1 is equals to ln S naught. They have told us 1272 and 1280. So 1272 divided by 1280 S naught divided by E plus into bracket R. R is the rate of interest 8%. So 0.08 minus Q is 2% dividend 0.02 minus 0.5 into standard deviation square. So standard deviation is 0.2, 0.2 square we have to. Okay, this entire thing we have to multiply it with t. So t is the time period. In the time period they've given is 48 days. So 48 divided by 365. This is the numerator divided by standard deviation, which is 0.2 into square root of 48 divided by 365. Okay, let's now solve this part so that this is square. So d1 is equal to natural log of 1272 divided by 1280. See how much you get? Minus 0.006269. See if you're getting this. Give me 1 second. All of you try if you're getting this. Natural log of 1272 divided by 1280.
Yes, ma'am.
Okay. 0. Now we'll solve the bracket. First we'll find the standard deviation square. So 0.2 into 0.2, 0.04 we get into 0.5. We get it as 0.02. So 0.08 minus 0.02 dividend minus 0.02 is the standard deviation square into 0.5. Once we get that, we have to do into 48 divided by 365. To get it as 0.005260 divided by 0.2 into square root of 48 divided by 365. 0.0725. So T1 is equal to minus 0.006269 plus 0.005260 divided by 0.0725. You will get minus 0.0139. Just see any other answer you're getting. Okay. Something we have done wrong here. It is 0.0948. Anybody getting this answer? 0.0948. I'll just 1 second. I'll just share the Had it solved already. 0.0948 is what I get there. And when we did it now, I'm getting it as minus 0.0139. So something I'm doing wrong. Just cross check any one of you what answer you're getting. I'll also check it once. Okay. Here is the mistake that we have done. Here it should be plus sign. Just see the D1 formula, R minus Q plus 0.5 into standard deviation square. And the original D1 formula also is the same, R plus. So for D1 we have to do plus. I took it minus looking at the D2 formula. So that's the reason there's an error. Let's just see now what we're getting. We get 0.01052, 0.01052. Now we'll solve and see. Minus 0.006269 plus 0.01052. Still I'm getting it as 0.0586. Is anybody doing along with me? Are you getting it as 0.0948 or you're getting this 0.0586? Anybody trying it? Sharvari, Shubham?
Yes, ma'am, I'm trying, but I'm getting some other answers only.
Ma'am, I'm getting D1 as 0.77.
0.77.
Yes, ma'am.
Okay, let's do this sum in the next class. I will see where and what is going wrong. Even y'all try at home. I've already given you the formulas. One error was here, there's a plus sign and we have
I
taken
think
minus
when the
sign.
mistake is in middle value, middle term, that is 0.08 minus 0.02. That term, I think.
R minus Q plus this term you're telling.
Yes, ma'am, even I think so.
Ma'am, that middle term value I'm getting 0.0626.
Just a second, what is the R? 8%. This you're getting
0.0626.
0.08 minus 0.02, you're getting it as 0.06, right?
Yes, ma'am.
Then 0.2 into 0.2, if I do the square, is 0.04. Into 0.5, if I do, it's again 0.02. So 0.06 plus 0.02, again it will become 0.08. This we have to multiply it with 48 divided by 365. So I'm getting it as 0.01052. How you are doing it, Shubha?
Ma'am, turn the entire term I am getting at 0.06. The whole term.
See, first you are finding the square and then multiplying it with 0.5 and then adding it to this, right? It's like this. First you have to do r minus q plus.
Ma'am, I put the entire equation in the calci.
Okay. Fine, I'll just check. We'll do it tomorrow. Y'all also try.
Ma'am, I am also getting 0.06263.
0.06 you're getting this term.
Okay. 0.0626.
0.0626.
Yes, ma'am, that term.
Let me try with this. So if we take 0.0626 and solve, what is the D1 value that you get? 0.7769.
0.77.
Okay. I'll just check what is going wrong here with me. I'm either doing something. Okay, this part I will cross check. So both of you are getting 0.7769, right?
Yes, ma'am.
Yes, ma'am.
D2, we can use that shortcut formula and solve. So just finish till D2. D2 is equals to D1, which is 0.7769 minus standard deviation, which is 0.2 into square root of 48 divided by 360. So 0.7766 minus 0.0725. 0.7041 you're getting. Shubham and Sarvari, are you getting this D2 values?
Yes, ma'am.
Should we complete the sum or you want me to do it tomorrow? If I complete this sum, tomorrow I can start with hedging strategies, or tomorrow we continue from here and then go to hedging. Just say yes, no, continue.
Excuse me, ma'am.
Yes, Sarvari. Tell me,
Ma'am,
Sarvari.
that 48 divided by 365, it is under square root
Yes, here, no?
for D1, 48 divided. Ma'am, actually, I had not taken the square root of that, so I was getting different answer from yours, maybe.
Denominator is under square
Ma'am,
root.
maybe then
Sarvari, numerator is not under square root.
numerator is not under square root.
No, only denominator.
Okay, ma'am.
Should we continue or should I stop here?
Ma'am, stop.
Okay, we'll do this tomorrow then. Tomorrow 1:30 I have my regular class. At that time we'll finish the sum and we'll start with the strategies of option trading, in which the first one is hedging. So you can leave the meeting.